I'd like to talk to you about KVH's newest inertial measurement unit, or IMU product, the 1750 IMU. But before I get into any specifics about the 1750 IMU, I think it'd be a good idea to briefly review the path that KVH followed to arrive at such an advanced 6 degrees of freedom sensor. KVH introduced the single-axis DSP-3000 and the DSP-3100 in 2004. We've produced about 40 to 45,000 of these since then. We then took this single-axis gyro, which is a fiber gyro with a bias stability of 1 degree per hour, and incorporated it into the CG5100 IMU. The CG5100 IMU is comprised of 3 DSP-3000s and 3 accelerometers that measure angular rates and angular accelerations. It's a very accurate, very excellent product for the markets that it addresses. KVH also offers the CG5100 in the same form factor with an embedded GPS receiver. That product's called the CNS5000. As you can see, the package sizes, weights, and accuracies of the CG5100 and CNS5000 products are extremely well suited for a wide variety of vehicles, platforms, and applications. However, our customers in many markets are constantly pushing us to improve our performance as well as to decrease our size, weight, and power consumption. So KVH took everything that we'd learned about the DSP-3000 and developed 1 and 2 axis configurations of a product we introduced in 2010 called the DSP-1750. As you can see, the DSP-1750 is much smaller than the DSP-3000, but we actually made some very significant performance or accuracy improvements in the DSP-1750, which is actually very difficult to accomplish when reducing the size of a fiber optic gyro. So just as we had done with the DSP-3000, integrating it into the CG5100 IMU and the CNS5000 inertial navigation system, we've taken the DSP-1750 fiber gyros and developed the 1750 inertial measurement unit, which we introduced to the market in 2012 and moved to production in early 2013. To recap, we have 3 DSP-1750 gyros and 3 accelerometers in the 1750 IMU. The typical bias stability of this product is 0.05 degrees per hour. Over the full operating temperature range, the bias stability is less than 1 degree per hour. I know it's a lot of numbers to throw at you, but I especially want to point out the bias stability of the 1750 IMU since it compares so favorably with other IMUs on the market. But KVH's 1750 IMU is readily available and compares extremely favorably in terms of price with competing IMUs in its performance range. In addition to its outstanding bias stability, the 1750 IMU also has excellent angle random walk, scale factor non-linearity, and scale factor over temperature performance. We accomplished this through a number of technology advancements, primarily proprietary algorithms and special processing techniques that allow us to achieve superior accuracy while at the same time reducing size, weight, and power. Of course, you can get the full 1750 IMU specification from our website or simply contact us. We'd be happy to help you learn more about the 1750 IMU and how it may be used in your system. The response to the 1750 IMU from our existing customers, as well as from various markets, has been extremely positive. The 1750 IMU represents the latest advancements in fiber optic gyro and IMU technology from KVH. We expect it to be able to address a much wider range of markets due to its size, accuracy, price, and versatility. The 1750 IMU also represents the baseline for a number of products that KVH is planning for the not-too-distant future. Check out our website, www.kvh.com, or contact us to learn more about the 1750 IMU and KVH's other fiber optic gyro products, as well as our planned product developments.